This is Geography 2104, Lesson 11, Spatial Analysis and Geoprocessing, Section 3. Geoprocessing is a way to create new data based on the layers you already have. Another name for geoprocessing is spatial data integration. In most cases, you will alter the geometric properties of the features in a dataset while controlling some aspects of how the subsequent attribute data is handled. Next, we're going to look at some of the geoprocessing tools commonly used in GIS analysis and available to you at ArcMap. These will include clip, intersect, dissolve, merge, and union. There are numerous other tools within geoprocessing, but you will probably use these for most of your work. Clipping. This process creates a new layer by using a polygon layer, or selected polygons from a particular layer, as a cookie cutter on a point, line, or polygon layer. The output layer contains information from layer A only. Layer B, or the cookie cutter, is only used to define the new boundary. So with clip, we're actually going to go ahead and create layers of common overlay. And in this example, I went ahead and created a center point for grassland and chemical spill. And what we're going to be using for the overlay is a buffer. Let's go ahead and create a quick buffer. Let's see, center, buff, overlay. And let's make it 200,000 meters. There's our buffer around our center point for grassland and chemical spill, and we're going to go ahead and use clip to find areas of commonality. I just want to point out clip can be found under analysis tools and extract, and geoprocessing and clip. It's the same tool. So in this instance, we're going to use clip from the ARC toolbox. I would recommend reading the tool help. If you don't have it expanded, you can go ahead and open up ArcGIS help, or read the short version. If it's hidden, you can hit show. So input features is features to be clipped, and in this example we're going to go ahead and use rivers, and clip features is what are we using to do the clipping. Here what we just created was our center point buffer. Let's say rivers clipped 2. Go ahead and save. And we'll go ahead and run it. There it is, and let me go ahead and change the color so you can see it. So there's our clip. One thing I'd like to point out, with the newly clipped file, we have the same, this will make more sense when we do our next example, the same exact attribute table as if we opened Rivers 4 is the original. Same idea. This will be contrasted with intersect in our next video. Let me go ahead and turn this off, and we'll go ahead and run clip one more time with all points. And then center point, not center point, we want to use buffer. Let's say sample points clip. Which should pull out all the points here, maintaining just the attribute table for those center points. Go ahead and change the color so you can see them. And there we have it. Again, this will be contrasted with intersect in the next video, but that is it for clipping. The intersect method preserves only those features falling within the spatial extent common to both layers. The features of the input file are intersected or sliced by the intersect layer. The attribute data from both layers are included in the new layer's attribute table. This is the intersect tool, and from last video I left up the buffer around our center point for grassland and chemical spill. and I've left open the attribute table of the clipped points from the all points file, which we named sample points clip 2. From this, I want to go ahead and show you the intersect tool, which again can be found under Arc Toolbox, and in this case, overlay, we have intersect, and again, under geoprocessing, we have intersect. The main difference here, we're going to go ahead and load, is we have multiple files we can load in, and we're going to go ahead and load sample points and our center buffer overlay, and go ahead and name it sample buff intersect. So we're intersecting sample points and the center buffer. So spatially, our file is exactly the same as the clip file. Let me go ahead and compare the two. This is the intersect and this is the clip. And I just want to point out, this is the sample points from the clip attribute table. And the main difference we have here is this is the attribute table from the intersect file. What it's done is, in addition to the data that comes with the point file, it has also appended on the data that comes from the buffer, which we have at 200,000, and then a bunch of supporting columns that we haven't actually filled in. That would be the main attribute table difference between clip and intersect, but again, I wanted to point out in the tool, you can load multiple different files to go ahead and intersect. That's it for intersect. Dissolving features in a layer coalesces features that have the same attribute value. This tool is extremely important if you are trying to create a new shapefile or a file with a coarser level of geography than your starting files. This is exceptionally handy if you need to build parent geography for a country or a region. So this is the dissolve tool. What it will do is it will go ahead and generalize based on a set of criteria that you've created. Generally, you can use it for things like what we're going to do here is take these county components of some states, Virginia, Pennsylvania, Maryland, and Delaware, and we're going to generalize them up to actual states. The file you see surrounding it, North Carolina, West Virginia, Ohio, New York, and New Jersey, I have already done that. So let's go ahead and take a look at the dissolve tool. We're going to run two different processes here. Just to point out again, it's located in two different places. In this case, dissolve is located under data management, generalization, and dissolve, or again, under geoprocessing. But let's go ahead and load. In here, input features, we're going to load DC, Maryland, Virginia, and Delaware. Now, it's going to ask you, let me go ahead and change the name. We'll say DC, etc., dissolve. It's going to ask you under what field do you want to dissolve it. This will be compared in the next analysis I show you to what happens if you don't select it. In this case, we're going to select state FIPS code, and what it's going to produce is individual state files like we have down here with North Carolina and West Virginia, because it's dissolving based on the number. So if your state is number 15, it will be dissolved and kept that as same as number 15. State number 50, it'll dissolve in that method. Okay, so it makes more sense if I show it to you. So we'll go ahead and dissolve based on state FIPS for Virginia, Maryland, DC, and Delaware. So now we have state files. So we have Virginia, Maryland, DC, Delaware, Pennsylvania. This chunk here is based on the files I'm using. It's just general files for demonstration purposes. Now, as a comparison, let's go ahead and turn this off. Let's say I decide not to select the state FIPS function. So we have DC, Maryland, and Virginia counties here. And let's say, call it DC, etc., dissolve all. So again, we're not selecting anything, and what should be produced is one giant blob of all these files without any state separation. Let's see. There you have it. That would be a dissolve with no actual field usage. And in our next video, I will show you how to, if we had a file here, let me turn this one off, and we've got state files here and state files here. The next few tools will talk about combining them. If, for example, you were given Pennsylvania, Maryland, Delaware, DC, and Virginia and needed to quote-unquote glue them into the other state file. That's what we'll talk about in the next video. The merge tool. Using merge is similar to union. A new layer is created from multiple layers, but their features are not intersected. Merge allows you to combine the features from two or more layers of the same geometric type. Example, roads in DC, Maryland, and Virginia can be merged into one shapefile. So in this video we're going to use the merge tool, but in last video we used dissolve to create generalized files for Virginia, Maryland, DC, Delaware, and Pennsylvania with a surrounding file of merged counties for North Carolina, West Virginia, Ohio, New York, and New Jersey. What merge is going to do is, since we have files of the same structure, it's going to basically glue them together. Merge can be found under Data Management and General way down in here, or again under Geoprocessing merge in here. So we're going to use our toolbox, and the two files we're going to merge are the DC file that was dissolved from last video, and then our Ohio, North Carolina, West Virginia, New York, New Jersey state file. And let's go ahead and name it example states 1, and hit OK. And one thing I want to point out before I hit OK is, let me go ahead and open our attribute table for, this is Ohio, North Carolina, etc., and our DC attribute table. So we can see state FIPS code in the Ohio file and state FIPS code in the DC file. Let's go ahead and hit OK. And what it should do is create a giant glommed on general file for all the states. And there we have that. Alright, so the reason I bring the attribute table out is I want everybody to take a look at what we have now. So the Ohio file, state FIPS, our DC file, state FIPS, and example states glommed on, all the files are now in one. That is it for merge. Finally, the union tool. Union creates a new layer by combining two polygon layers. The new layer has data and shapes from both layers, including their intersection. In fact, union differs from intersect only by the fact that all the features of both layers are included in the resultant layer, including those features that did not overlap. So with union, we are creating another spatial overlay. In this example, we're going to use grassland and chemical spill. But for comparison between union and intersect, with union, we're going to retain an area that is just for chemical spills, which will look roughly like this, and this little divot over here, and divot over here. An area that is just the grassland, which would be this green area, this little spike here, and additionally, an area that is the actual intersect between the two. Now for comparison with intersect, again, it'll just be the common area. So to find union, we're going to go ahead and check overlay, and union is here, and again, is also under Geoprocessing. So we're going to go ahead and take grassland and our chemical spill area, and we'll say grass chem union. So we have a big mess here that is easier to parse out with the attribute table. So again, we have 3 polygons. I'll go ahead and highlight them in turn. We have our grassland area, that is just areas that are for grassland. We have our chemical spill area, again, that is just areas that have the chemical spill. And then we have our intersect area. Now let me go ahead and run a quick intersect. So selection, clear selected features, check grass chem union off, and intersect grassland and chemical spill, and we'll say grass chem intersect. And we have just the area that is common between grassland and the chemical spill. Now, for comparison again, we have our area here with certain columns and with grassland. Let me go ahead and turn this off and the union back on. We have exactly the same between the two. Grassland 2, polygon 0, etc. And then chemical, let me turn that back off real quick. And selection, clear selected. Exact same attribute table. Let's see, flash, there's that one. And flash, that one again. So polygon, FID, name, chemical, name 1, same one, name, FID, chemical, name 1. Same exact thing, except the difference being with union, again, is we have the areas that did not intersect added as well. That is it for union. This is the end of section 3. In our 4th and final section, we will discuss an overview of spatial overlay analysis and advanced analysis techniques.